Okay, so for number 11 on our review packet, what we're looking at is we've got to try to find a way to map this figure onto that one using a sequence of rigid motion transformations. So the way I might do this is try to look at orientation first. Now, what does orientation do for us? Well, it tells us if it's going to be a line reflection involved, or if we can just get it done with, um, you know, no line reflection or two line reflections. That's kind of what I'm looking at. So let's check out the orientation first from A to B. So you kind of gotta identify which order you're gonna go in. A to B to C has a clockwise direction or arrangement, so that's its orientation. Now, I have to map it onto DEF. Okay, so we got to get the letters in the same corresponding order. Start at D, go to E. Whoops, I went to F. Sorry. Start at D, go to E, and it looks like we're going in an opposite direction. We're going in a counterclockwise. So what happened? It was not preserved. Here's what that tells us. We need an odd number of line reflections to do this then. Okay, so 1 line reflection, 3 line reflections, 5 line reflections, whatever it's going to take to reverse the orientation. So I'm going to go with 1, and what I'm looking at is if I reflect over the, let's say I reflect over a line that is horizontal, I'm still going to have to rotate or do something to the figure. I'd rather not do that. So what I think I'm going to do is I'm going to stick to line reflections that are vertical lines, and hopefully that's going to make my my sequence a little easier to manage. Otherwise, like I said, I just don't want to have to rotate too. So I'm going to use probably line reflection over a vertical line and then a translation to map it. Okay, so let's start with this. Let's just reflect over so the first one that I have to write, let's reflect over the y-axis to map triangle ABC to triangle A prime, B prime, C prime. And just to make sure, that you're getting full credit for a question, go ahead and just do that. It takes a couple extra seconds, and it's worth it if you're gonna, do this. Do it right. So we'll take a minute, and there's B prime, there's C prime, and A prime. So, okay, so that's where we land. That's pretty nice. If you want to mention it, it can't hurt to do that. It's going to be at 6, 5. B prime is at 3, 1. And C prime is at 6, 1. Okay? It's good to identify that. And then what you're going to do is then translate triangle A prime, B prime, C prime down how many units? We're going to match C to F, so it's going to be 1, 2, 3, 4, 5, 6. Down 6 units. Okay, to map to map triangle ABC, A prime, B prime, C prime to triangle DEF. Okay, now this part is AC equal to DF. That's actually something we took out of the chapter, so it won't be on the test, but it's good to know what's going on here. The answer is going to be yes first, then the explain part is why. Okay, now AC and DF are corresponding sides, and here's what we're going to say. Because when rigid motion transformations can be used to map one figure onto another, the figures must be congruent. Okay? Uh, then their corresponding sides must also be congruent. Or you could say, here's another way to do this, probably a little more simply. I'm realizing it might be an easier way. You could say translations and line reflections. So we could use the terms we've already been over. They preserve length. That might be more related to the topic this time. You know what? That's what I'll go to, because this is actually, this is going to be next chapter. So let's just say they preserve length, because that is a property, and we're more in properties this chapter. So, all right, describe two unique transformations. Whoops, I did not finish the other problem. Okay, it did say two. All right, let me create some space and get a set. Okay, so let's go back up. I got to finish that. I didn't get two. All right, so now I'm going to go to a second sequence. All right. So what I'm going to do for my second one, to get this unique idea, maybe I'll try two different moves. Actually, I can't. I have to perform a line reflection somewhere. Okay, but let me go over, I'll make it a little tougher. Let's go over the x-axis. So C prime would land there, B prime would land there, A prime would land there. Okay, and what I noticed is I could possibly do a point reflection through the point 0, -3. B would then map straight through. Okay, it's 1, 2, 3, 1, 2. So you could move over 3, down 2. Do that again, and it does land there. A does the same thing. It lands on D. So we could do a point reflection next to finish it off. So what I'll do is I'll say what A prime is. Looks like -6, -5. B prime is looking like -3, -1, and C prime -6, -1. Okay, so let's go write this out. The sequence that I'm going to use next is I'm going to reflect triangle ABC over the x-axis to get triangle A prime, B prime, C prime. Then, let's see, yes, reflect triangle A prime, B prime, C prime through point 0, -3 to arrive at, let's see, triangle DEF. Okay, again, same thing, translations. No, we used line reflect and point reflect preserve length. So that's the property we're going to use. All right, do another one here. Let's see. Map triangle ABC to triangle DEF. To me, one of them looks like I could go straight through. Yeah, it looks like B is going to go to E. I could map straight through the origin. So here's one of them. Let's point reflect triangle ABC through the origin. to land on triangle DEF. That's that simple. You're going to be able to do that pretty easily. That's going to work. The second one, I need two unique ones. Okay. What if we did... Now, one of the things that I did before I even started the problem was I did check orientation. So that's kind of why I knew this. So if I look at triangle ABC, we talked about this last time. That is a counterclockwise orientation. Right? We're reversing the clock direction. And then if I go DEF, which they have to, that's how it has to land, we're still going counterclockwise. So basically I looked without even saying that. I looked at it and I thought, all right, orientation was preserved, so I knew it's going to be an even number of line reflections, or just use something else. Rotation, point, reflect, whatever. I say even number because the first line reflection would switch orientation, the second one would switch it back. That's what I'm going to do next. So to get the unique one, I'm going to reflect triangle ABC over the x-axis first. And then, when you do this, make sure that you draw it. Okay? To get triangle A prime, B prime, C prime. And if you plot that, it really strengthens your case a lot. Somebody can see you're actually showing it and proving it. Then reflect triangle A prime, B prime, C prime over the y-axis to map to triangle DEF. Okay. Is the angle, so we got to explain that one. So the answer to that part is yes. And let's use properties again. Point reflections and line reflections must preserve angle measure, or congruent angles, or whatever. Angle congruence. Okay? That's it for this video. We'll pick up on the next one.